So hello everyone, my name is Katie. I am a long-time PHP developer. I am here today to talk about monoliths and legacy code architecture, because that is something that I, for some reason, enjoy, even though most other people don't. So I have been a professional developer since 2009, and in that time, pretty much every job I've had, every company I've worked for has had a big legacy code base, a monolith, if you will. I currently work for a company called Verona, and they too have a big legacy PHP monolith. At my prior company, Skillshare, also had a big PHP legacy monolith. And I was sat one day just doing a job, working on the Skillshare monolith, and everyone hates it, right? And I thought, monoliths are kind of like ogres. And here you can see Shrek. Shrek is an ogre. And I remembered a quote from Shrek, that ogres are like onions, because they have layers. You may have seen a diagram like this before. It's an architectural diagram of a system, and it too has many, many layers. This is an onion. You can see it has many, many layers. So I was sat there thinking, hang on a second, is this monolith actually an onion? And I looked for some other signs that maybe I was correct and that a monolith is in fact an onion, and I came up with a few. One, of course, there are many layers. It smells, or at least all of the engineers in your company, your colleagues, think that it does. I don't know if you've ever tried it, but if you did bite into an onion, it probably would taste quite strong and you wouldn't like it very much, which kind of is what it feels like when you have to work on a monolith. And last but not least, it makes you cry. I think many tears have been shed in the time that we've spent working on monoliths. So today, I'm going to take that analogy and I'm going to run with it, because that's one of my hobbies. I know quite a lot about onions, actually, because one of my main hobbies outside of programming is gardening, specifically growing vegetables. And one of the first vegetables I ever grew was onions. So I know a lot about onions, and I know a lot about big legacy monoliths, so I'm going to just put the two together, and we're going to talk about that today. So what you notice about an onion is that it has lots of layers, and you start from the outside, and you can peel off the individual layers. You've got the outer skin, and then you can just keep peeling until you've got a little stub. And I'm going to use this analogy to explain hexagonal architecture and the dependency inversion principle. First of all, here is a diagram of an onion. You can see that there are leaves, which are what show itself to the outside world. That is equivalent to our presentation layer. Then we have our papery thin skin on the outside, and that is our application layer. And then inside that skin, you have more fleshy layers, and that is the bulk of the edible onion. That is the bit that's important. It's the bit that contains all of the nutrients and nourishment, and that's the bit you would eat. And if you were to just keep peeling off all of the layers, you would get a little stubby thing at the bottom, and that is a stem. And if you were to flip it upside down, that's where all the roots come from. So the roots are on the outside of the onion. So botany of an onion translates into coding, or like application architecture. So as I said, our flowers and our leaves are our presentation layer. They are above the ground, they grow out of the ground, and it's what we see of the onion when it's growing. We don't see anything under the ground. And because I'm a big fan of onions, I've included some fun onion facts. Onions are biennial, which means that in the first year of growth, they focus all of their efforts on growing and swelling big and getting the big onion shape. And then it's in the second year that they would start to use that energy to develop flowers, which then turn into seeds, which is how an onion would reproduce. So the presentation layer of the onion is kind of aware of all the internal layers, but it's the only part that's visible to the outside world. And in our code bases, these look like HTTP routes and API entry points, GraphQL stuff, and HTML, and God forbid, JavaScript. The next layer is the skin of the onion. This is the bit that's very papery thin. It dries out. You can peel it off. And this functions as our application layer. It facilitates safe interactions with the internals of the system. The purpose of this layer in an onion plant is to prevent things like diseases and viruses and pests from attacking the nice fleshy internals, the good part of the onion. So this layer would contain things like the orchestration of the access to the internal layers. Oh, and fun onion fact, this is also known as a tunic. So this layer, in terms of our application code base, would be things like controllers. They don't actually do anything. Controllers are thin controllers, fat models, that kind of rhetoric. They just make sure that what enters your system is valid. Like you can validate requests, reject ones that are inappropriate, and also service providers. So it puts together how, or the rules or the contracts for interfacing with the onion system. Then you get to the good bulk of the onion, the bit that's tasty. It's the bulk of the system. The layers inside an onion are still separate. So even though you have one onion and it's a big bulb and it's fleshy, if you were to cut it in half, you would see the multiple layers inside this onion. And the same is for most of our applications, is that there are multiple layers of functionality within our entire application. And each of those is distinct from another. So we can separate the layers from one another. Fun onion fact is that these leaves are actually succulent leaves. So they're the same kind of leaves as you would get literally on a succulent plant. They absorb a lot of water and nutrients. They're like a storage system for keeping nutrients for the onion's growth. In terms of our architecture, the bulk of our system would be implementations of our domain model abstractions. So this is the business logic, the algorithms. Things like services and helpers and processes. Basically, most of our code would be in these layers. Keep on peeling, and you're left with the stubby bit. This is the base. It's actually a stem. So a stem is something where the bottom of it has roots coming out from it, and the top of it has leaves and flowers coming out of it, in botanical terms. So yes, an onion plant does have a stem, and it has the leaves, the fleshy layers coming out the top, and then if you were to turn it upside down, you'd get roots. It's just very, very short and very, very fat stem. The base of an onion, or the stem, contains stem cells, and people know that stem cells have the unique ability to essentially grow any other kind of cell. So in architectural terms, this is what our core domain model would be. This is where all of our concepts and interfaces live. They don't actually do anything in and of themselves. There's no code here. It's just instructions. It's abstractions. It's contracts. So in terms of our architecture, you find these kind of things as entities and aggregates and value objects. They're sort of the core building blocks of our system. And then last but not least, you have the roots. Roots bring in nourishment from the outside world. And it's the same for our application infrastructure. It's not something that reaches out to the world like the leaves and the seeds and flowers do. It's something that brings stuff from the outside, and it anchors our application to the ground. It anchors the onion to the ground, and it's the same for our application, right? Our applications generally depend on a lot of external services and a lot of external infrastructure. So that's essentially what our roots are. And like plant roots, this should be very well hidden from the public. Like no one on the outside should be able to know really what's going on under the ground. And that's a way of protecting our system. This is in the form of SDKs. You've got your databases and ORMs, frameworks, although you might think that they're part of the core of your application. They're not really. They're actually, a third-party dependency that you're including into your system. So it forms part of this root and this nourishment from outside. And any adapters that you have that translate what you've defined in your core domain model to something that can, an implementation provided by a specific third-party tool or framework or whatever it is. So I hope that you now have a good idea of like what an onion looks like, and if you were to cut an onion in half, you'd be able to say, oh yeah, that bit's there, that's a stem. Did you know that's a stem? Fun facts. And how, likewise, our giant legacy applications can be sliced, and you'll probably see multiple layers, and you have your core domain model and your infrastructure, and it all kind of makes sense, right? So now that we understand what an onion is, we have to talk about how an onion grows, or how these kinds of systems become built in the first place. And I'm going to, again, run with this analogy and try and explain domain-driven design in terms of onion growth. So if you wanted to plant some onions, as I have done in the past, you can't just chuck onion seeds out into the middle of nowhere. Like I couldn't put some onion seeds on the floor here. They wouldn't grow. So likewise, before you start doing any kind of coding, you should take the time to talk to the people in your area, do the groundwork, survey the landscape. That means talking to domain experts and business stakeholders, which quite frankly probably aren't you. You probably think you know a lot more than you actually do. So it's really important to talk to the other people that are actually going to be using your system and have problems that they want solving. So understanding those problems and encapsulating them into things like user stories. And you can also use API schemas and things like that at this stage to essentially define what it is you're doing, where you're putting your code, why you're building it, what you aim to solve by planting this seed. Then after we've got a good understanding of like, yep, this is a good place. I know that if I plant an onion seed here, it's probably going to grow, and I know what I expect it to grow into. I'm not planting a leek seed by accident. So a seed is very small, but it contains all of the information required for an onion to grow and enough nutrients to sustain it until it can grow roots and leaves to get some energy from sun and the soil. So in this stage, you would define your entities and value objects. So entities, interfaces for entities, and value objects. So to explain these two things, an entity is essentially an object that has a life cycle and it can be identified. So for example, a user in a system is an entity. A user can go through stages of a life cycle. They register, they become approved, and then it can be deleted. So it has a life cycle. And it can be uniquely identified. Two users with the same name are different users, even though all of their properties could be technically identical. To contrast, a value object is something that doesn't have an identity and it doesn't have a life cycle. It just is. So an example of a value object might be an address. A user has an address, and a user's address can change, but the address belongs to a house, and that doesn't change. Two people can have the same address. It's not two people with two different addresses that technically are the same. It's literally the same address. Another example of value objects might be email addresses, telephone numbers, currency types, So, you know, a euro is a euro, no matter where you are. So, yeah, when you define all of these, your value objects can be concrete classes because they're quite distinct and they have a set state, some rules for validation. But your entities are probably defined as interfaces, they're contracts, they contain the rules for growth. And all of that put together is considered to be your core domain model. Again, it's the instructions required for growth, it's not the actual growth in and of itself. That comes next. Once we have our core domain model, we can use that to implement all of our business logic. This is the algorithms. This is how we decide whether a user is active or not. It's the bulk of our system. And with onions, each layer within the bulk of our system is distinct from other layers. And that comes across in our architecture in terms of bounded contexts. So a bounded context is where you have some references to your core domain model, but they differ in the way that they're understood and used depending on the context. So let's take an HR system, for example. You have people, right? Some of those people could be job candidates. Some of those people could be administrators. Some of those people could be employees. But they're all people. So although person is an entity, in different contexts, it means different things. In the context of managing like job applications, you have candidates and you have interviewers. But those same people in a completely different context, in the context of an HR system, where they're employed, you know, a person in the job candidate domain becomes then a hired employee, and those two things don't really interact with each other. They're two distinct and separate contexts and layers. It's important to note that remembering our onion and that layers peel off from the outside in, you can't access an inner layer without peeling off the outside layers. And if you're in an inner layer, you can't reference, like once you've peeled it off, it's gone. You can't go out, you can only go in. So all of our business logic can only reference our core domain. They can't reference the leaves or the flowers or the roots or the skin. It's all gone, it's in an outer layer. It's invisible. So just bear that in mind. Then once you have some of your fleshy onion layers, you probably want to integrate with some infrastructure, third-party infrastructure. This is where you would set root to support yourself, remembering that the roots bring in things from outside. And so there's a concept of ports and adapters. Port is like a plug socket, you plug something into it. An adapter is the thing that you've plugged in, right? So your business logic and your core domain model can expose these ports to say, oh, I expect some sort of storage mechanism here. I don't really care what kind of storage mechanism it is. It could be a database, it could be a file system, it could be an in-memory cache. I don't care, all I know is that I need storage. And then you'd have an adapter that adapts, say, MySQL or a cache system to fit into your port. And that is how you would essentially plug those roots in to your core domain. So if we're trying to keep things as framework agnostic as possible, because there are so many frameworks and sometimes one isn't really working out for you, this ports and adapters pattern is one to really bear in mind because it allows us to switch out our implementations. So as long as we've got those abstractions defined in our core model, then we can plug in whatever we want, as long as we adapt it. So once you have your onion, it's growing lovely, the leaves are swelling full of business logic, and the skin develops around it. This is where you would build in your controllers. It's usually something that you sort of do last, maybe, I guess. Once you've got all your logic in place, you can start to expose this to the outside world. This would be essentially service providers. So most frameworks have some sort of dependency injection container sort of implementation where you would essentially say, okay, so when something asks for this abstraction, I'm going to give it this concrete implementation. So if there's something requests a database connection, I'm going to give it MySQL. And that's great because you can swap them in and out. So like we were talking about in the onion, botany of an onion, is that this papery thin layer doesn't really do anything, but it does facilitate how things interact with each other. It prevents things from being accessed in the wrong place. It's where your validation would live. And then finally, once your whole system is put together, it's well protected, it's got all the infrastructure that it requires, and it's done its first year of swelling of the business logic, it can start to send out leaves and flowers and things like that, which essentially is your front end. And I'm not going to talk too much about that because, like most of you here probably, I'm a back-end developer, although Michelle said that PHP can be used as a full-stack framework. I don't think that that is really done because everyone loves JavaScript too much. So anyway, I tried to explain domain-driven design, and I hope that some of it made a little bit of sense. And I can see that you're all sat there thinking, yeah, that's all well and good, but like, I'm not developing anything new. I'm not trying to grow an onion here. I have an onion, and the problem is it's all mashed up. Someone's gone at my onion with a knife, and it is in tiny, tiny dice. So I don't know what to do with it. Okay. It's okay if your onion is all like chopped up. There are ways of dealing with this, okay? You can make an onion much more palatable if you know how to cook it. And if you cook it, then it will stop your eyes from hurting, okay? I really love this book and also Netflix series by Samin Nosrat, Salt, Fat, Acid, Heat. These are the 4 elements of good cooking or coding. Remember I said I really liked analogies. Anyway, if you haven't seen her Netflix series, it's great, you should check it out. So I'm going to look at how we can make our onion or monoliths more palatable if we just bear in mind the 4 good cooking requirements. Okay, so we're going to start with salt. Samin says about salt is that the 3 basic decisions involving salt are when, how much, and in what form. Salt isn't a flavor, okay? It doesn't really, I mean, it tastes of something, but it's not really a flavor in and of itself. What happens when you add salt to food is that it just magically tastes better, okay? Like, I'm sure you've all experienced that. You've had some really bland food that someone's just like, I don't know, boiled some vegetables and you're like, God, I really don't want to eat this. But then you just get some salt and you put it on and you're like, ah, that's better. Cool. So yes, it's knowing when to put salt to your food. Too much, and it'll be completely overpowering. Too much salt is bad. You can't actually taste the food at that point. Your mouth just burns. So in terms of salt, we're going to talk about clarity in our application architecture. That means adding comments to our code, but only when necessary, because too many comments and it just tastes like salt. Remember I mentioned before ubiquitous language, which is the language spoken by business stakeholders and people that are experts in the domain. We're going to use that because when we use a ubiquitous language, things are understood. That's the idea. Everyone understands what you're talking about. You don't refer to job candidates as anything other than job candidates, because that's the word that everyone uses when they're talking about job candidates or interviewees, depending on your business. We're not going to go overboard with our salt adding, and we're going to reference explicit types because PHP is a typed system. All of our objects and our values and things like that have types, and that defines or makes clear what the objects are used for. So I'm going to go through a few do's and don'ts. So here we have an example of something that I see quite often, but I find quite overpowering. Is that the comments here exactly echo what the code is saying, okay? You have my permission to delete those comments. It's fine, don't worry. Not everything has to have a doc block, and yes, your code can, to an extent, be self-documenting. The exception here is that in this method, for example, it might throw an error, and there's currently no way to type hint that. You can't say, oh, this method could return bar, or it might throw an error. So adding a comment for the errors that it throws is really good, useful, and makes things more clear. So remove the stuff that we don't need and add the stuff that is omitted or can't be inferred from the type system. Cool. This is a case where it needs more salt because, for example, like the props, and we don't know, all we know is it returns an object. We don't have any information about what that object contains. So using types, like whether that's value objects or entities, things like that, we can be way more explicit about the structure of the data. Sometimes we do need to use comments, like for example in this order interface here, when we return an array of items, but at least we're specifying there that it is an array of items, not just an array of God knows what. So I feel like, you know, that's a lot clearer than the before thing. Adding salt here clarifies things a lot. Did you know there's also like loads of different kinds of salts, and different salts are good in different situations? Like I had a colleague who had a whole talk on salt and different types of salt, and like, you know, pink salt, smoked salt, sea salt, table salt. Yeah. So anyway, I feel like this is a case where, okay, it's got salt, like all the information is there, but we could handle this a little bit differently by rewriting some methods, adding different comments, and just, you know, making things clearer. I think that if you write a method that has like and in the name, or if you write a comment that says things like, it does this and also does this, or does this maybe sometimes, it should probably be in different methods. Yeah, like keeping things small is a good idea in terms of clarity. So here we separated out some methods, and we've added some appropriate types and type hints, and it should be a lot clearer. So a little note for something like this is completely rewriting some methods, and I understand your legacy code bases, you can't always do that because these old methods are in use, and you can't just go deleting everything because, you know, maybe there's some magic code in your code base that gets a variable and then calls the method based on a variable name, so you can't even search it in your IDE. Okay, you just have no idea whether this method's being called or not. So you can use a deprecated annotation in a doc block. If you just put an @ symbol and then deprecated, you can also type a little reason and give a reference to an alternative function to use. So I highly recommend that, yes, you can go ahead and do stuff like this. Please, feel free. But just leave the old method intact and tag it with deprecated. And then when you're sure that it's not being used anymore, you can just delete it. You can also add logging to deprecated methods, so you can find out whether it's being called still. And if you don't get any logs for a certain period of time, then you just consider it safe to delete. Cool. The next element of good cooking is fat. Fat tastes good, okay? Like, if something doesn't have fat in it, it's just not going to taste good. It's going to taste bland. It gives things substance. It gives things flavor. But if you have too much fat, it can become stodgy. Like if something's excessively greasy or, yeah, fatty, it's not maybe the greatest. So this is where I'm talking about keeping things lean, keeping our code base nice and clean and only containing what is essential for its flavor and not any of the extra stuff that doesn't really add anything, and keeping it from being stodgy. So in a lot of our code bases, you'll find lots of unnecessary methods. Things like getters and setters. I'm sure you've all got a file in your code bases that's like get set, get set, set, get set, get set, all the way down. That's a lot. Considering whether things should behave in the way that they do, things that maybe can result in an invalid state, or something is mutable when perhaps it shouldn't be mutable. Just, you know, trimming it down, keeping only what's necessary. So for a few examples, this is our lovely getters and setters. This is a very small example. But if you think about it, like, especially in terms of the ID, that kind of thing doesn't change, right? Once there is an ID, it's set and it doesn't change. So having a setter there for a set ID is redundant and can like result in some sort of invalid state where you've given an object an ID that doesn't actually belong to it. So it's better if we just make those read-only. Names can change, but as Derek mentioned in his talk, you know, names are way more complicated than what you think you are, what you think they are, and there's like a whole website on common things that developers don't understand about names, which is a list of all the things about names. Like, you think that names have like a first name and a last name. No, they don't. You think that a person can only have one name. No, they don't. They can have, or people have two names, and that you can get just people with one name, or that names don't change, or that names aren't assigned to you until you're a certain age, or that you're not born with a name sometimes. So anyway, just like these are the kinds of things that you can think about in your system. Is this thing really changeable, or is it not? And remove those excess setters. And constructor property promotion is great for this as well. In this example, we have, again, some getters, a lot of getters, and they're all returning a kind of scalar type. But this is a really great place where we can use some value objects. So as I said earlier, value objects are things that are identified by their properties. They don't have an ID and a lifecycle of their own, but the real benefit to using value objects instead of strings and scalars and things like that is that they can be validated. So for example, in the original example, a phone number can be any arbitrary string. There's nothing to stop me from typing some random text or sentence into there, but it's not a valid phone number. So by creating a phone number value object, you say, okay, this is what a phone number is. It consists of that many digits, and if you try to give it something that isn't a phone number, it's going to error, and it's not going to work. So that saves you a lot of headaches in terms of validation. Yay. And here we have, I wonder if anyone can spot the issue here. I can set my birth date and set my age. So I might have typed in my real birth date, but then just set my age to 21 because I don't want to be any older than that. And the entire object is in a invalid state. Yeah, because you can't, like, my birth date is mismatched with my actual age. So again, it's being aware of like what it is about your objects that are changeable and what is kind of fixed, and also what can be computed from the data available that you don't want to have like a setter for example. So in this case, I've just said, oh, we can set the birth date and that will determine your age. You can't set your age, but you also can't get your birthday because once it's entered, like maybe we don't want to expose that data. Yeah, like if we're running a social media platform, you don't necessarily want people to be able to access someone's actual birth date because it's kind of private information, right? But you can at least tell them your age. So it's reducing the number of places where this data can be accessed. And also, when it comes to entities, remembering that entities have like a life cycle. They go through different stages and states and things like that. And with this example here, we have a status. So the status could be, well, I don't know what, it's the status. Maybe it is, well, in this example, something can be published or archived, for example, but using get status and set status doesn't actually tell us anything about the life cycle of that object. It's better if we can use functions that actually explicitly state what the stages are. So, and this allows us to perform validation. So if one object can't move directly from created to archived, it has to go through a state of published, then you can make sure that if you call archive on something that is already published, or like you can't publish something twice if it's already published, or you can't archive something that's deleted, or delete something that's archived, I don't know what. But yeah, so think about the life cycle of your entities and use appropriately named methods. And again, remembering the deprecated tag to remove the old methods that don't add any substance to your system other than just stodge, and start using the new methods and then delete the old as you go through. The next principle of good cooking is acid. So acid adds complexity to dishes. Using the right acids for the right things can balance the flavor of a dish. So I probably should have mentioned this earlier, but when it comes to onions specifically, okay, you can take an onion, peel off the papery layers, rub it in olive oil, which is your fat, put salt on it, put it in the oven, like low and slow, and then after a while it comes out, it caramelizes, and it tastes good. And you can drizzle some balsamic vinegar on that as well to make it extra good. So yes, these 4 elements of cooking can make anything taste good, even just a whole onion. So in terms of balancing the flavors of our system, we're talking about dependencies. So making sure that things aren't intermingling with each other when they perhaps shouldn't. And that these bad flavors are mixing with each other and everything tastes bad. So don't reference specific infrastructure unless you're in the infrastructure layer. Don't, layers mingling together. And always reference abstractions and not concrete implementations unless you're in the application layer and your service provider. That's the D in Solid, that's dependency inversion. Anyway, do's and don'ts. In this example, it's kind of a little tricky to see, but in the top class, you have something that is in the domain or the core domain namespace that's in your stem, I suppose, of your onion. And then you have a reference to a service, which would be a fleshy layer. Those are two different separate layers that the domain layer is referencing something on the outside. It can't do that. It doesn't have access to that. The service layer can only reference layers inside, not outside. So instead, you would create an interface, and that serves as a port into your domain services. And then in our service layer, we can implement our domain model abstraction. And then those two layers aren't tied to get together in a way that they shouldn't be. Another similar example is that here we have something in a service layer that's directly referencing our infrastructure. So the fleshy layer of our onion is somehow having access to the soil or the roots of the onion, which is impossible, as you know, unless you were to peel an onion and chuck it on the floor, which is probably what happened to your monolith. So bearing in mind that instead of having something like this, we can have our domain abstraction, and that in this scenario comes in the form of a repository. So a repository is responsible for fetching and storing data, for example, so that you don't have to reference the actual database in your code. You can just reference this repository layer, and then it's up to your application layer, the skin, to determine what exactly database-wise your repository is accessing. Then we have something like this, which is a repository. And so, yes, I suppose this is like it's an implementation of a domain layer repository. So it's kind of in the right place. It's in the infrastructure layer and it's referencing the domain. But it is directly calling a new connection to a database, which is bad because that is hard-coded and it's impossible to change. Whereas if we use dependency injection by passing in a database connection as part of the constructor, then we can technically change that implementation. So we could have a different MySQL implementation, I suppose. And then we could use the same, as long as that connection, it defines an interface. So the method in getBars, the execute method still exists. And that allows us to switch things out. And it allows us, importantly, to test things because we can give it a mocked version of our database. So we don't have to create a whole active database or have available a database connection in our unit tests, for example. Something that is really helpful for keeping track of all this, because these kinds of like leaking dependencies and things depending on layers that they shouldn't have any dependencies on is really hard to keep track of. So I recommend going and installing this static analysis tool, DepTrack. You can use it to define the layers in your system, and by default, it won't let any layer access any other layer. So remembering our onion is that the outer layers can look in, but the inner layers can't look out. And you can set up your whole configuration to say which layers can interact with others. So, for example, everything can reference your domain layer, but nothing in the domain layer can reference anything outside of that. And you can essentially do it based on namespaces. So, for example, you might have your app domain, and then your app services and your app infrastructure. And that's a really good way of keeping track of where your dependencies are and what they're interacting with. Cool. The last thing that I want to talk about is heat, and that is performing under pressure. You don't want to apply too much heat to something because it's going to burn, but if you don't apply enough heat, it's not going to taste good. If you put an onion in the oven for 2 minutes, it's still going to be an onion, okay? It's not had enough time So we've got to make sure that our applications can perform well under pressure and produce the right results. And that would be related to testing. So a few generic rules for testing is you test the implementations, not the abstractions. Don't mock things unless you absolutely have to. And don't try and test private methods. Don't use this like reflection class and then call a private method, like make it public and then call it. Like a private method is an implementation detail. You shouldn't need to test it. Shameless plug, I have another talk. I'm not going to talk about testing here because I've done that before. So please, if you want to have a full experience of another, hopefully very humorous talk about testing legacy code, please feel free to find my video here. And just waiting for people to take a picture of that. Go, go, go. Cool. But I really, like, if there's one thing that I can talk about and like really impress in everyone here about testing is that please, please, please do not mock the system under test, okay? This is a bad idea, because when you're mocking the system under test, you're not actually testing anything. Of course it's going to pass because you've told it to pass, not because it's actually executing any code. I see this a lot, okay? If you have this in your code base, it's okay, no shame, but just please go and fix it. Mock only what you need to mock. That is things that are outside of your control. Things like API endpoints or databases that you don't necessarily have access to in your unit test suite. But if you don't have to mock it, don't mock it. It's better to test things in like a real world scenario than something, you know, in a vacuum. Like theoretical, in a vacuum, this would work perfectly, but you know, your system isn't in a vacuum, okay? Better yet, you don't even need to use mocks at all. As long as you have your architecture where you've got a lot of abstractions and contracts and interfaces, you can use this anonymous class to create an implementation of your interfaces, of your things in your domain layer or whatever. You don't need to have a concrete implementation available in your unit tests. And this is not a new feature of PHP, this is an old feature of PHP, okay? We could have been using this for a long time, but people don't. But now you know, so you don't even need a mocking framework. You can use an actual real implementation of your abstractions. So that's pretty much it from me. So I'm going to do a quick recap, and then that'll be a short. Come on. So in the aim of not collecting underpants, I've also put in some homework tasks here. So today, hopefully you've learned about the architecture of an onion and how this applies to your big legacy monolith and its multiple layers, and how you can only access layers from the outside in, not the inside out. So your homework today is to identify the layers in your system and go and install DepTrack and get it running and see what it throws out at you. Then I hope you've learned a little bit, not too in-depth, about domain-driven design and how you could use it to add new functionality to your existing systems. So I advise that, you know, no matter where you are in your legacy system, when you add something new, approach it from that angle of growing an onion. Think about the domain-driven design. Think about your entities and value objects. Speak to the business stakeholders and domain experts, and approach things in an incremental manner. And thirdly, I hope I've given you some tips and tricks for dealing with code and writing clean code, so that hopefully the next time that you bite into your monolith, it doesn't really hurt your eyes and your mouth, and things are a lot more palatable. Please feel free to delete redundant comments. Promise you don't need them. Use refactoring, use dependency injection, use a deprecated doc block annotation to your heart's content, and everything will be well. So anyway, that was me. Thank you for listening.